Okay, guys, we're going to go over how to graph exponential and logarithmic functions. So let's start with y equals 2 to the x. Okay, so it's pretty easy to find the y-intercept and the x-intercept, right? So if we remember, the y-intercept is where we cross the y-axis. So that means that x has to be 0. So when x is 0, y is 1. So we know we have a dot at 0, 1. To find the x-intercept, it's where we cross the x-axis, we need y to be 0. Well, there's no solution there because 2 raised to a power can never be 0. So we don't cross the x-axis. All right, for the end behavior, we basically want to see what happens as the x's get really big. So we're going to take the limit as x goes to infinity. And we see that the y's are going to approach infinity as well. So there's no horizontal asymptote here. As the x's get really big, the y's get really big. Okay, in the other direction, though, we might have a horizontal asymptote. So we take the limit as x goes to negative infinity. If you do like 2 to the negative 1,000, right, that's going to be 1 over 2 multiplied 1,000 times. It's going to get really tiny. So it's going to get closer and closer to 0. So we do have a horizontal asymptote at y equals 0. All right, so that's like a decent sketch of y equals 2 to the x. So for b, for the domain, there's nothing that we could put in for x that would make this undefined. So our domain is reals. And then for the range, we saw that y couldn't be 0. 2 with an exponent will always be positive. So for our range, y is greater than 0. All right, for c, we want to sketch a graph of the inverse function. So we have to remember that to get the inverse function, we switch the x and y coordinates on the original. So you can see here, we had a point at 0, 1. Well, on the inverse, that means we'll have a point at 1, 0. Now, you've done this in Algebra 2, but that basically means that whenever we want to graph an inverse function, we're just reflecting the graph over the line y equals x. And it might help you to understand that better if you just pick some more points and you can notice the pattern. So when we do that here, our graph is going to look something like that. So this is the graph of f inverse. And this was the graph of f of x. Okay, for D, to find the equation of f inverse, as we said, to get the inverse function, we switch x and y. So we have like x equals 2 to the y. So now to get the variable out of the exponent, we're going to take the log of both sides. And now we're going to finish solving for y. We'll divide by log 2. So we have that the inverse is really equal to log base 2 of x. All right, and now for the domain and range, that's pretty easy because we know that we just switched the x and y values on the original, which means that that will just switch the domain and range. So the domain is now going to be x is greater than 0, and the range is now going to be reals. Okay, let's try one more. So let's go to number 3. So for 3, I suggest when you have to graph a logarithm that you just first find the inverse, solve for the inverse. I guess I should have asked maybe the question a different way and asked you to solve for the inverse first. But whenever you want to graph a logarithm, I would suggest first just solving and putting it in like an exponential form, and then like getting the inverse, and then going back and getting the original graph. So let's just start by finding the equation of f inverse. So we're going to switch x and y, and now we're going to try to get y by itself. So let's divide by -1, and then we'll rewrite this as 3 to the negative x equals y, which is the same as 1/3 to the x. Either one is fine. All right, so you could write it either way here. Okay, so now let's see how we would graph this. We know that the y-intercept will be 0, 1. we know that there's no x-intercept. And when we look for the end behavior, when x gets really big, we can see that y will get closer and closer to 0. And when x gets really small, we can see that y will get really big. Okay. All right. So for the domain and range, we can see that we could put in anything for x. There's no x value that would make 3 to the negative x undefined. And then for the y's, you can see that you can't get 0. Like 3 with an exponent will never be 0. And you know that 3 with an exponent really always has to be positive. So for our range, it's y is greater than 0. Okay, so let's sketch out our graph of this inverse function. So we know that we have a point at 0, 1. We know that when the x's get big, the y's stay close to 0. We know that when the x's get small, the y's get large. So this is a graph of f inverse. Okay, to go back to A and B, to get the graph of f of x, all we have to do is reflect this over the line y equals x. And we can see really easily, okay, instead of 0, 1, 1, 0 is a point. And then we need to try to flip the rest of this. So we're going to flip this piece here, like that. Oh, sorry, that wasn't perfect. It's going to look something like that. It's going to go up, but not cross the 0, because this line doesn't cross the x-axis. And then we have to flip the other piece from the second quadrant, and we go like that. So this is our graph of f of x. All right, now we want the domain and range for the original. Well, again, just switch the domain and range from the inverse.